Hello, you Sanction nerds. Welcome to Calc-cool-us. I don't know what's wrong with me. Okay, here we have the integral of square root of 1 minus x squared times dx. Okay, so as usual, I want you to try this out by yourself. Okay, this one, you're gonna need a trig sub.
This is a very tricky integral, or should I say tricky integral, you know?
Alright, you try it out. So the trig sub we're gonna do is, trust me on this one, let's let x equal to sine theta. Alright, so let's replace that. Okay, so let's call this integral I. It's integral I. So then I is going to be integral of square root of 1 minus times sine theta. Sine squared theta. And add the dx. So we have square root of 1 minus sine squared theta dx. Alright, so the problem is we have to convert this dx into d theta because we have this new term. Okay, so if I take the derivative of this dx with respect to theta, I'm going to get cosine of theta. Alright, so that means dx is going to be cosine of theta d theta. Alright, cool. So, so I'm going to replace that now actually. I'm just going to cross that out. And dx is going to be cosine theta d theta. Alright, so I've replaced the x term and I replaced the dx term. Okay, so this is kind of like a use of logic. So now the question is, how do we continue? Well, if you recall that, put this down, we have the Pythagorean boy.
Because we have our Papa Pythagoras.
Sine squared plus cosine squared equals 1. So if you subtract 1 minus sine squared is equal to cosine squared. So I'm going to replace that here. So this turns into square root of 1 minus sine squared is cosine squared. Cosine squared of x times, well, I'm just going to bring, well, actually, sorry, this is theta. Okay, times cosine of theta d theta. If I have a square root of a square, that cancels out to give me cosine theta, times another cosine theta is going to be cosine squared theta. Integral cosine squared theta d theta. Perfect! Does this look familiar? We just did this problem using the double angle formula. Okay, but now we have it in terms of theta, so we're going to have to work with that later. Okay, so if I replace the double angle formula one more time, I'm going to do 1/2 d theta plus the integral of cosine of 2 theta d theta. So I'm using this double angle formula and I'm replacing the cosine squared, okay, which hopefully you've seen before if you saw the last video. So if I do that, this is going to be 1/2 the integral of constant is just that variable, so this is going to be theta plus, oh, I forgot the 1/2 here. Sorry about that. So then this is going to be 1/2 times another 1/2, right? Just like the last video of, sine 2 theta. Okay, so technically we're done if we just add plus c, but this was in terms of x, so we actually want it in terms of theta. So we have to, replace the theta. So if we have here x equals sine theta, well, I'm just going to write down that if you solve for theta, what would that be? What would that be? You have to take the inverse of x. So theta is equal to sine inverse of x. Okay, so I can simply replace this theta term into each of this. So this would be 1/2 times sine inverse of x plus 1/4 sine of 2 theta. Okay, so wait a second. Let's see what happens. Sine of 2 inverse sine of x. Okay, so that's a little bit weird. Sine of 2 times inverse sine of x. I don't like a trig function with an inverse function inside of that function. So let's not use that, okay? So I'm going to stop this part. Let's consider something else to replace that theta term. Recall another formula from trig. Sine of 2x is 2 times sine of x cosine of x. So this is actually still going to be 1/4 times, well, now I'm just going to replace that term with what we have there. So this is going to be 1/4 times, I'm going to write down 2 times sine of x, 2 times sine of, well, here we still have theta, so this is still going to be sine of theta times cosine of theta. Okay. All right, so this is better. So if I replace that theta term again, I'm going to write it over here, if that's cool with you guys. Okay, so I'm just going to rewrite it. 1/2 sine inverse of x, that stays constant, times 2 over 4 is plus 1/2. Okay, so I can write sine of theta, which is inverse sine of x. Cool. So I automatically know that these are going to cancel out to give me just x. Okay. But the question is, what is cosine of theta? Cosine of sine of theta? Sine inverse of x. So again, what is up with these inverse trig functions inside of another trig function? Okay. So instead of that, thank you to Dr. Payam.
With Dr. Payam.
Hello! And this is especially for my calculus students right now. The question is, what is cosine of theta in terms of x? And for this, as I already pointed out, use the triangle method.
We have the triangle method. So let's keep this as cosine of theta again. Cosine of theta. So the question is, what is that cosine of theta term? So if we recall from trigonometry or geometry, if we draw a triangle, okay, triangle is nothing other than, this is a theta, and we have this relation. If x equals sine of theta, it might be kind of silly to think of sine of theta as x.
But remember, abracadabra, sqrt, sine of theta, that's really opposite over hypotenuse. And x over 1, that sounds like opposite over hypotenuse.
Over 1. So from the triangle method, if we have sine of theta as x over 1, so katoa, sine of theta is going to be opposite over hypotenuse, where opposite is x and hypotenuse is 1. And again, from our Pythagorean boy, we have x squared plus something squared. We don't know what that is quite yet. Something squared equals 1 squared. Okay, so what else do we have? Okay, so if we solve for that something, well, we can write another relation. Cosine of theta is what? So katoa, so ka, adjacent over hypotenuse. Adjacent is something over hypotenuse, which is 1. Okay. Alright, so all we have to do is actually just solve for that something. And that something is going to be 1 minus x squared, right? I'm just simply solving for that something. And lo and behold, look, we solved for theta as a function of x. So cosine of theta is actually going to be, cosine of theta is actually going to be simply square root of 1 minus x squared. Wow, isn't that pretty cool? Isn't that pretty neat? So we have 1/2 times sine inverse of x plus 1/2 times sine of x times cosine of theta, where cosine of theta is square root of 1 minus x squared. That's brilliant. I'm sorry if this is messy, guys. I'm still working on my penmanship. So just gonna squeeze it down here. The overall answer for the integral is 1/2 times sine inverse of x plus 1/2 x times cosine of theta, which is 1 minus x squared. And we are done. Oh my god. Don't hate me. I know. Professors, don't Stop. Shh. I forgot plus C. I know. So imagine that I have the same answer, but then I put plus C, okay? Alright. And that's it. You know, sometimes integrals can be really tricky, but sometimes they can be pretty cool. So to recall, I know this one was a little bit messy. That's why we've done the previous two integrals. We've done cosine of 2 theta, and we've done cosine squared of theta. And you just have to recall a couple little trig functions, as well as the triangle method, which is very neat if you ask me. We plug those guys in. Oh!
While engineering pulls himself together, let's see how Spud.
We've done a lot of different types of math tricks in this video, so if this is confusing, I quite understand. But this is the last hint for the tank problem, if that's what you're doing. Alright? So if you're doing that tank problem, consider this. Okay? That's it for this video. Don't forget to share this with your friends, family, and your dog.